Hello everyone, in this video we will learn how to find out the definite integral as limit of sum. See, if there is any continuous function fx be a continuous function in the interval AB, then definite integral of the function fx from a to b represents the area between the curve and the x-axis from A to B. How we can understand this? If we draw the curve for the function y equal to fx, suppose this is the function and it is in the positive direction of x-axis. This is your point x is equal to A and this is the point x is equal to B. In between this, anywhere if we draw a strip, vertical strip of width dx, it will be just like a rectangle or not. And this is suppose y which is equal to fx. Can we say that the area of the strip will be equal to y into dx, or we can say fx into dx, that is length into breadth. Now if we integrate this particular function from A to B, will it cover the complete area of this region or not? So we can say that integral from A to B fx dx is equal to area of the region between x-axis and the curve from A to B or not. The region for the function y equal to fx from A to B, when we have drawn, this is suppose like this is x is equal to A, this is x is equal to B. If we divide it into n sub intervals, this is one of the interval, this is another interval, and so on, we continue and divide it till this, and we are dividing it into n intervals. Divide the region in n sub intervals, each of width h. If this is h, can we say that this point is x is equal to A? Then this point will be A plus h, this point will be A plus 2h, and so on. So the first point here we are getting, first point is x is equal to A. The second point will be A plus h. Third point will be A plus 2h. Same way, when we continue, the nth point will be A plus n minus 1 into h. So this point is A plus n minus 1 into h. And the last point, that is x is equal to B, will be A plus n into h. Can we say from this that h is equal to B minus A upon n or not? Now if n is very large, say n is tending to infinity, then certainly h will be very small and that will be tending to 0. What about the area? See, if this point is A, this length will be f of A or not. For the second strip, we will find that if this is a plus h, certainly this length will be f of a plus h and so on. This length will be f of a plus n minus 1 into h. The area of each strip can be found out by using length into breadth, because they are just like rectangles, you can see here. And if we add the area of all the strips, that will be equal to the area of this complete region, which is equal to the definite integral of fx from a to b. So the area of region can be taken as the sum of the areas of all the strips, which is equal to the area of the first strip is h into the length, that is fa. So it is h into fa. The area of the second strip will be h into f of a plus h. The area of the third strip is h into f of a plus 2h, and so on. The area of the last strip will be h into f of a plus n minus 1 into h. And since we have taken n is very large, h is tending to 0, then can we say that from a to b, integral of fx will be equal to limit h tends to 0. If we take h common from each, this will come as fa plus f of a plus h plus f of a plus 2h plus so on f of a plus n minus 1 into h. It means we can represent the definite integral of the function fx from a to b as the limit of sum. To apply the method of finding the definite integral as the limit of sum, let's take some of the problem. The first one of them is integral x dx from a to b. Now we can see here function fx is x and the limits are from a to b. It means we can write here b minus a upon n is equal to h. It means n into h is equal to b minus a. Now starting from the lower limit, we will find out the values of the function fx at different values of x. Like we find here fa is a. fa plus h, that will be a plus h. f of a plus 2h, that will be equal to a plus 2h, and so on. F of a plus n minus 1 into h will be a plus n minus 1 into h. And now we'll write, since integral of fx dx from a to b is equal to limit h tends to 0 h into fa plus f of a plus h plus so on f of a plus n minus 1 into h. Therefore, a to b x dx will be limit h tends to 0 h into, substitute the values, fa is a, fa plus h is a plus h, f of a plus 2h will be a plus 2h, and so on. This is a plus n minus 1 into h, which is equal to limit h tends to 0 h into a plus n times we are adding, that will be equal to n into a. And from all these terms, that is second term of this, if we take h common, this will be 1 plus 2 plus 3 plus so on up to n minus 1. This is equal to limit h tends to 0 h into na plus h into, is it sigma n minus 1? That is sum of n minus 1 natural numbers, equal to limit h tends to 0 h into na plus h into n minus 1 by 2. We know the sum of n minus 1 natural numbers is this, We are applying the formula here, sigma n is equal to n into n plus 1 by 2. If we multiply this h inside, this will be limit h tends to 0, nh into a plus this will be nh into nh minus h upon 2. What we have done? 1 of h we have multiplied with this, equal to limit h tends to 0. We substitute the value of nh, which is b minus a into a plus b minus a into b minus a minus h upon 2. Now we apply the limit h as 0. This will be b minus a into a plus b minus a into b minus a upon 2 because h is 0. If we take b minus a common, we are getting here a plus b minus a upon 2. This is equal to b minus a into b plus a by 2, or it becomes b square minus a square by 2, which is the answer to the problem. To find the definite integral of an exponential function by using the same method, that is definite integral as limit of sum, if we take the problem ex dx from a to b, here we find fx, the function is ex. The limits are from a to b. It means we can write b minus a upon n is equal to h, which implies that nh is equal to b minus a. Now we will start from the lower limit and find the values of this function. That is, fa will be e power a, fa plus h will be ea plus h, f of a plus 2h, that will be e to the power a plus 2h, and so on. F of a plus n minus 1 into h will be e power a plus n minus 1 into h. Now we know the formula. Since integral of fx dx from a to b is equal to limit h tends to 0, h into fa plus f of a plus h plus f of a plus 2h plus so on, f of a plus n minus 1 into h. Therefore, integral of ex dx from a to b will be limit h tends to 0, h into, apply these values. This is e power a plus e power a plus h plus e power a plus 2h plus so on, e power a plus n minus 1 into h. If we take e to the power a common from here, we are getting h into e to the power a, and it will be 1 plus eh plus e2h plus so on, e n minus 1 into h. This is a GP in which we are finding a is equal to 1, r is equal to eh, and n is equal to n. We know the sum of n terms of a GP, that is given by a into r to the power n minus 1 upon r minus 1. If we apply that particular formula here, this will be limit h tends to 0, h into a to the power a, and this will be here 1 into e to the power nh minus 1 upon e to the power h minus 1. We can write this as limit h tends to 0, e power a, e to the power nh we can write as b minus a minus 1 upon e to the power h minus 1 upon h. We have brought this h here. We know the limit e to the power h minus 1 upon h is equal to 1. We write here limit h tends to 0, e power h minus 1 upon h is equal to 1. And when we apply that here, this will be equal to e to the power a into e to the power b minus a minus 1 upon 1. which on simplification comes as e to the power b minus e to the power a, which is the answer to the problem. In the next video, we will learn about the properties of the definite integrals. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.